All right, guys, so this is going to be part 2 of our review. I just wanted to stop here because 10, of course, has tons of solids that we're going to be finding information of. And some of these have really weird kind of quirkiness to them because they have like other little clues that you have to use inside the formulas. So we'll get to those here in just a sec. So I'm just going to start with A, of course. So it's asking for the lateral area of this equilateral triangular prism. So the first thing I'm going to do, of course, is write the formula for the lateral area of a prism, which is just pH, right? And of course, that's a really easy calculation because P is just perimeter of the base. And of course, my base is a 10, 10, 10 equilateral triangle. So of course, his perimeter is 30 and the height is 6. So obviously the lateral area of this guy is 180 square meters. And I know there's a blank up there to write that in, but for the sake of time, I'm just going to leave that boxed, okay? All right, next up is a cylinder. Notice the clues here. They want you to find the radius given the lateral surface area. All right, so we're using formulas in reverse here. So again, you want to write down your formula. If they give you the lateral area, which they're just using L, you can write L or LA. It makes no difference to me. So the lateral area of a cylinder is 2 pi RH. So we're just plugging in the 120 pi. Again, if you want to make things easy on yourself, since there's a pi on each side. Oh, I'm so sorry. Let me actually plug in the height of the cylinder because it's 10, right, from the picture. Sorry about that. And so if I cross out the pi's, I just get the equation 120 equals 20R. So obviously I'm just going to be dividing by 20, and that gives me a radius of 6 meters. Right, and that is our answer. I don't know what happened to the box over here. Sorry, my stuff just keeps deleting. And that's a square. There we go. Okay. All right. Moving on over. See, it has a little bit of a twist to it, right? They want you to find the height of the cylinder given, this is kind of weird, 2 clues. They're giving you the volume, which of course means I'm going to be using the volume formula, right? So I'm just going to go ahead and write that down. Pi r squared h. But notice they didn't give you the radius or the height, but they did tell you that the radius is equivalent to half the height, which is pretty awesome because that means wherever I see an R, I'm going to replace that with a 1/2 h. Because technically I can't solve this equation because it has too many variables, right? But if you tell me the volume is 250 pi, and then you tell me that the radius is half a height, so I'm going to replace the R with a 1/2 h, and then I have the h multiplier over here. So we haven't really done anything like this. We have seen fractions that are squared, of course, because from the SPOV chart day, right? And so we know that when we're squaring the h, we also have to square the multiplier in front of the h. All right, so let's see, I'm going to take this one little step at a time so I don't lose anybody. So that's going to give me pi, and that's going to give me 1/4 h squared times the other h. Okay, if everyone's cool with it, I'm just going to go ahead and divide out the pi's and just get rid of that because we don't need those there. So that's going to give me 250 equals, well, that's going to be 1/4, and h squared times h is h cubed, right? Because you add the powers when you multiply. And that's the equation I'm going to use to solve for h. So I'm simply going to do what I would do for any algebra equation that has a fraction in it. I'm going to multiply both sides by 4, which is going to give me 1,000 equals h cubed. And then I'm going to cube root the 1,000, which has got 3 zeros, so the cube root is going to be 10. And it doesn't really give me any units. I was leaving space for units, so I'm just going to put 10. I'll just put U for units. So yeah, Voila. That one's kind of different, right? But nothing too crazy. All right, let's go with this guy. They want us to find the height given the volume is 468. Okay, now it's important to notice that this is a trapezoidal prism, right? A lot of people confuse this and they're like, it looks like a frustum. This is not a frustum because frustums have trapezoidal sides, right? These are not trapezoids. All of the sides are rectangles, right? You can clearly see that in the picture. All the lateral faces are rectangles. It's just the front and the back are your trapezoid bases, right? So here's our trapezoid base. Get rid of that purple, right? And there's one on the front and one on the back, right? And so we clearly know that this is also 16. I'm just going to go ahead and label that. And the volume is 468. All right, so volume equals capital BH because it's a prism. Well, remember, I'm just going to throw this all in the mix here if everyone's cool with that. The area formula for a trapezoid is 1/2 the height. Oh, I'm going to use a bracket here. So half the height, which is what I'm looking for, times base 1 plus base 2. So 16 plus the 10. So that's the capital B. And then we're multiplying that times the height of the entire prism. Well, the height of the entire prism is the distance from trapezoid base to trapezoid base, right? And so that is going to be our 12 over here that we're multiplying that whole bracket by 12. Oh, and I may as well, sorry, instead of writing that all again, since the volume is 468, let's go ahead and replace the V with 468. Again, you can piecemeal this and go kind of simplify the area of the trapezoid, but at the end of the day, we are trying to find the height of the trapezoid, so I'm just going to kind of write that all into one giant equation. All right, I'm going to clean this up. Again, baby steps, just so I don't make a silly mistake. So I'm going to go ahead and just do all this first, right? So clearly 16 plus 10 is 26. And then I'm going to take half of that, which is going to give me 13. So that's all going to be 13H inside the brackets. And that's getting multiplied by the 12. Right, so now I can multiply the 13 times the 12, which is going to give me 156H equals 468. Right, and then I can just divide, and I'm going to get H equals 3. And that would just be units because they didn't actually give me units on that volume. Okay, so again, being able to work an algebra equation, right, no matter what piece is missing or what pieces were given. Okay, so solving for the height. All right, next up, E. E also, they all have their own little twist. E also has a little twist in that right here, let's see, let me get a pink. I just want to point out that this is not the slant height, right? So you want to be really careful. This is the edge of the pyramid's face. Okay. They want us to solve for the lateral surface area. Well, that formula is 1/2 PL, which means I do need the slant height, right? But the slant height is this, the height of the triangular lateral face, right? So this is the right triangle that I'm creating, right? And this is the L. And then, of course, I know this is 6 because it's a square pyramid, and the slant height would be splitting the side in half because those are equilateral triangles. Okay, so I have a little right triangle with a hypotenuse of 10 and a base of 6. And if you know your Pythagorean triples, then that makes pretty light work of this, right? So this would be 8, right? Because that's going to be a 6, 8, 10, or a 3, 4, 5 Pythagorean triple. Again, if you don't know that, that's okay. Just go off to the side really quick and do a little Pythagorean theorem using that edge as the hypotenuse, right? And so you're going to get L squared equals 64. So L equals 8. Awesome. And now you have everything you need, right? So my lateral area is 1/2. Clearly the perimeter of the square is 48, right? Because 12 times 4. And then we just found out that that slant height is 4. So all we have to do is throw all that in our calculator, and that is going to give us 192 square meters. All right. We're making our way through the alphabet. Here we go. Letter F. All right, so on this one, it's just wanting us to find the volume. It's clearly an a hexagonal prism. So the volume is going to be BH because it's a prism. And of course, the hardest part of this is finding the area of the base, right, from Unit 6. So I'm just going to kind of go over here. You don't actually have to draw the hexagon, but we do need to drop the apothem and do all this lovely work. Right, there's my right triangle. You should know that this top angle in any hexagon is 30 degrees. If you do not remember that, then the top angle is 360 divided by 2n. Right, so you would be dividing 360 by 12. Remember, n is the number of sides, and that would give you 30. And we also know that each edge of the hexagon is 4, and we know the apothem splits that in half, so that would be a 2 base, which clearly means, let me erase that so I can scooch that over a little bit, that our apothem is 2 root 3, right? Because it's the 2 is the short leg and the apothem is the long leg, so we're using our special right rules. Please remember, do not use trig on hexagons. You are going to miss the question. Your trig might be correct, but you must use special right triangles first before trig. Trig is used when special right triangles can't be used, right? So you're going to lose major points if you use trigonometry on a hexagon. Okay, so just don't do that. All right, so I still need to calculate the area of this hexagon base, which is going to be your 1/2 AP formula for regular polygons. Well, we just found out the apothem is 2 root 3, and clearly the perimeter is going to be 24 because there's 6 sides of 4. And then you can just do all that math in your head, or you can use your calculator. Obviously, half of 2 is 1. 1 times 24. So the area of the hexagon is 24 root 3. We want to keep our answers exact, of course. And now that we've done all that work, we're golden, right? So now my area of my base is 24 root 3. So I'm going to go put that over here. And then the h, of course, is the height of the prism from hexagon to hexagon, which is 6. Sorry, my screen keeps jumping around on me. And that's going to give me 144 root 3 meters cubed. All right, moving right along. G, volume of a sphere. Gotta love the spheres, right? Because it's just a little easy formula. There's only the radius is the only variable, but please do not forget that the radius is cubed in the volume formula, right? So this is just 4/3 pi 12 cubed. And you can just type all that in your calculator minus the pi, right? So I'm totally just typing in 4/3 times 12 cubed. And I'm getting 2304 pi cubic centimeters. And voila, that is it. Love spheres. Okay. All right. What letter are we on? H. All right. So H, they're asking us to find the height of this prism given the surface area is 208. Okay, so let's see. Obviously, if you're given surface area, then you want to use the surface area formula for a prism, which is pH plus 2b. Now, obviously, we are looking for this H, which means you totally want to be using, right, the top and the bottom as your bases when you're doing this calculation. I'm not saying you can't do it the other way, but obviously if we're solving for that H, we want to make that the H, right, in our formula that we're looking for. Make it easy on yourself. All right, so here we go. I can just start plugging in what I know. If that is the base, I know the perimeter is 8 plus 4 plus 8 plus 4, right? Because if that top is 8, then so is the bottom there. It's a weird looking 8. There we go. So what is that going to be? 24 times the H that we're looking for plus 2 times the area of the base, which would just be 8 by 4. So 32. And I don't know why I keep doing this. I keep forgetting to write the actual thing on the other side. So the surface area is 208. I keep forgetting that. And you can see from there, it's a pretty easy algebra equation, right? So again, I'm going to take this in baby steps. So 208 equals 24H plus 64, right? So we're just going to subtract 64 from 208, and we're going to get 144. Equals 24H, so H equals 6 meters. And that's what we were looking for. Okay. All right. 10 and 6. Wait. That is so weird. Okay. So the picture for I is basically the same picture as A. Just kind of noticing that. But this one's different because it's asking for volume. Okay, so here we go. It's the same equilateral triangle. Notice it gave us the lateral area, which is going to be really important because now I know you could go look at A, but let's pretend that we didn't actually have that question up there. So if they gave me the lateral area, that means I need to use the lateral area formula. So this is kind of going to be multiple parts. So here we go. The lateral area of a prism is pH. Okay, so that's 180 equals the perimeter times the height. So that means solving the algebra equation that the perimeter is 30. Well, if it's an equilateral triangle, right, then that, of course, clues me in that, if the perimeter is 30, that each one of the sides has to be 10, right, because we're evenly dividing the perimeter into 3 congruent sides for our triangle base. Now, excuse me, we should be able to find the volume, which is capital BH. So now that I know it's a 10, 10, 10 equilateral triangle, right, again, I'm going to find his area, which again, I know I've already done this before, but we're going to treat this problem as if we didn't already have that information up there. So we know that this is a 30, 60, 90. We know that this side length is 5. So our height is 5 root 3. So then when I do 1/2 base times height for the triangle, I get 1/2. The base of the whole triangle is 10, and the height is 5 root 3, which gives me 25 root 3. So I'm going to take that. I'm going to go back up here, 25 root 3. And of course, the height of the prism is 6. So that means our volume is 150 root 3 cubic meters. Uh-oh, I did not want an arrow. There we go. Let me go back. I'm just going to look back at this one really quick. Okay. All right. Oh my goodness. On to J. Here we go. They want the total surface area of the cone. Okay. Clearly, I'm going to need the radius at some point for this, right? And if you do your Pythagorean theorem, right, because you have your slant height, right, with your height, with your radius, right, all creating that right triangle, right? And we've already talked about this. Clearly, the radius is 6. This is a 3, 4, 5 triple. That's been doubled, right? If you don't know that, again, you can do your Pythagorean theorem and you're going to get 6. Okay, so total surface area of a cone. Let's see. So that is going to be pi RL plus pi R squared. I almost forgot for a second. All right, and we basically have all that, right? So pi, the radius we just found, the slant height that was given, plus pi 6 squared. So we're going to get 60 pi's for the lateral plus 36 pi's for the area of the circle base. We're going to add that together, and clearly that's going to give us 96 pi. And that would be square meters. All right, moving along. This one is asking us for total surface area of the prism. Okay, so PH plus 2B. Again, you can pick any sides you want on a rectangular prism to be your bases. I am just going to use the top and the bottom, not for any particular reason, right? Just because, but I'm going to make a note of that in my picture so I don't forget when I pick my height and all that stuff. So if I'm using those as the bases, let's see, this is also 6 meters. So my bases are 2 plus 6 plus 2 plus 6, which is going to give me a perimeter of 16, which means the height of my prism is going to be the 3 meters, right? The distance between my two bases. And then, of course, the area of my bases are each 12. And voila, right? That's going to give me 48 plus 24, which is going to give me 72 square meters. So there you go. I kind of feel like they're getting easier, right? A little quicker as we go. All right, letter L. Again, they gave you the lateral surface area, but notice they're wanting you to find volume. So again, this is going to be a multi-step question because I have to use one formula to solve for a missing variable so I can solve for another formula. Okay, so obviously if all we know is the lateral area, then I need to just use the lateral area formula for the cone, which is pi RL. And I'm going to plug in what I know. So 65 pi equals pi. I don't know the radius, but I do know the slant height is 13. Okay, so again, like we've been talking about, you can just kind of omit the pi's because they'll divide out of each side. So we're essentially just dividing both sides by 13, which is going to give us 5. Which is awesome because now I know, I'm just going to cover over that if everyone's okay with that. The radius is 5. And yes, to do volume, I do need the height of my cone, which again is just a quick little Pythagorean theorem. And if you know your triples, then the height's going to be 12. That is a 5, 12, 13 Pythagorean triple. If you don't, again, a quick little Pythagorean theorem off to the side. Pretty quick and easy. So now that I know that my height is 12, now I can go use my 1/3 pi r squared h to actually solve for the volume that it wants. So 1/3 pi, the radius of 5 squared, times the height of 12. And then I'm literally just typing all of that in my calculator except for the pi. So the 1/3 times 25 times 12, which is going to give me 100 pi cubic meters. So we use the lateral area to solve for the radius so that we knew the radius that we could plug in to the volume formula. Okay, moving on. M is a right triangular prism, and it wants the volume. Well, the volume of any prism, sorry, I'm going to scooch this over. The volume of any prism is area of the base times height. So I am going to need the area of the base, which is just a right triangle, right? So that's just 1/2 base times height. and you're given the base and the height because those are the two legs that create the right angle, right? So the base is 8 and the height is 6, or vice versa. It really doesn't matter. And so that's going to give me an area of 24 for my triangle bases. So that means I'm just going to plug a 24 in for the capital B. And then, of course, the 7 is the height of the prism because that's the distance from base to base. And I just throw that in my calculator, 24 times 7, and I'm going to get 168 cubic inches. Look how quick we're getting. There we go. All right, letter N. Letter N is a cube. Remember, you should know all of your cubic formulas. They are not on your formula chart. So just as a reminder, LA is 4S squared because there's only 4 lateral faces. SA is 6S squared because there's 6 faces total. And volume, since it's 3-dimensional, is S cubed, right? S times S times S. So you need to know those for your test. So this one is giving us that the lateral is 100 feet. Okay, so clearly I'm going to be using the LA equals 4S squared, and we're going to be plugging the 100 in for the lateral. Well, this is a really easy problem when you know your cube formulas, because all you have to do is divide by 4, and that gives you 25 equals S squared. So we'll square root both sides to solve for S. And so voila, the side lengths are 5 feet. Let me scooch that over so I can get my unit in there. And that's it. That's what it was asking you to find, the side length of the square. That gives you a lateral area of 100. Okay, so that's why those formulas come in so handy. I'm going to scooch those a little closer. There we go. All right, O is another hexagonal. I wish there was an octagonal prism on here or something that requires trig. That makes me sad. I should really fix that. Okay, so just make sure you go back and look at an octagonal prism or something that requires you to do trigonometry. I don't know why there's not one on here. All right, so this one is basically similar to the other hexagon we did, but it only wants the lateral, which is pretty awesome because lateral is just perimeter of the base times height. So that actually makes pretty darn fast work here because the perimeter of the base is just going to be 48 because there's 6 sides of 8, and then the height of the prism is 16. Right, so I'm just multiplying 48 times 16, and voila, I'm getting the lateral area is 768 square meters. All right, so that one is nice and quick. I didn't have to find the area of the base, right, because I don't need that for lateral area. All right, P is a little tricky, right, because they're giving you an added clue down here that the apothem is equal to the height of the pyramid. So that's kind of weird, like letter C that we did earlier. So here we go. They want you to find the volume. Okay, so I'm going to write down the volume formula, which is 1/3 capital BH, because it's a pyramid. Okay, so what they're saying, let me go up in the picture here. It's a square pyramid. So let's see, if I drop the height, right, and I kick out, right, because here's my slant height, right? Remember, every cone and every pyramid contains a right triangle, right? Every single cone and pyramid contains a right triangle with that slant height, right? This is your slant height. And then I know this is 10, and that is the apothem. And they told me here that the apothem is equal to the height of the pyramid, which means, I know it doesn't look like it to scale, right? But that means that the height is also 10. So that little clue is just kind of helping you get 2 pieces of information that are not labeled in your picture. Okay? And now you should be able to do the volume pretty quickly here, right? So it's going to be 1/3. Clearly the base is a 20 by 20 square, so that's going to be 400. And then the height is 10. Now 400 times 10 is 4,000, and that is not divisible by 3. So I'm just going to leave my answer exact as an improper fraction, and I'm just going to leave it as 4,000 thirds cubic meters. Okay. All right, letter Q. You knew we had to get to it sometime. It's a rectangular frustum, right? And so we just learned that big volume formula the other day. I'm going to go ahead and write that down really quick. So 1/3 H times B1 plus B2 plus the square root of the product of B1, B2. Okay, and so my height is 12, so I'm just going to write this up here. They gave that to me. The area of the top base, which I'm going to call B1, it doesn't matter, is this 2x3 rectangle, so clearly it has an area of 6. And then B2 is going to be my second base down here, which is an 8x12 rectangle, which gives me an area of 96. So I have everything I need. I just need to throw it into my formula now, right? So I'm going to get 1/3 the height of 12, and then 6 plus 96 plus the square root of 6 times 96. Now, luckily for us, right, 1/3 of 12, finally something that's actually an even third, is 4. And then 6 plus 96, right, that's going to give me 102. And then in my calculator, 6 times 96 is 576. And luckily for us, that's a perfect square. So that whole square root right here is 576, and that is an exact 24. So yay. So I'm basically doing 4 times 126, and that gives me 504 cubic meters for the volume of the frustum. And again, I know he's a frustum because clearly the lateral faces are trapezoids, telling me that this was a pyramid, right? All my faces here are trapezoids. So I know this was a pyramid at one point, right, where the top got chopped off. Right, so I don't want to confuse that with a trapezoidal prism. Oh my goodness. Okay, so we're almost there. So letter R. So again, they want the total surface area, right, the S. This is a prism, a right triangular prism. So here we go. PH plus 2B is our total surface area. All right, so let's see. The first thing I need is the perimeter of the base, which I do not have completely because my right triangles are my bases, and the perimeter would require me to know the hypotenuse. It is a Pythagorean triple, so if you know them, great. If not, again, you can just do a quick little Pythagorean theorem up here. Or you could recognize that it's a 3, 4, 5 Pythagorean triple that's been quadrupled, right? And so we're going to get 400. So clearly the C is 20, which makes perfect sense because that's the 5 that's been quadrupled. So now I can fill in the capital P. The perimeter of my base is what, 48? And then, of course, the height of the prism is the 10 because that's the distance from right triangle to right triangle base. And then I need to add on the areas of the two bases. Well, they're just right triangles, so that's just 1/2 base times height. And I love right triangles because obviously the two legs are the base and the height. That's going to give us 96. So each one has an area of 96. So let's see, what's that give us? 480 for the lateral, right? What is that, 192, right? For the total of the two bases, right? And we throw that in our calculator. And we should be getting a total surface area of 672 square meters. All right. Oh my goodness, finally, our last two. Letter S. All right, so it's another sphere, but they're giving us the surface area of the sphere. So that means we need to use the surface area formula, which is 4 pi r squared. So again, spheres only have radii, so that makes them nice and easy algebra equations. Again, feel free to just cancel out the pi's on both sides because they're going to divide out anyway. So when we divide by 4 on both sides, we're going to get 9 equals r squared. And when we square root, we're clearly going to get 3 meters for the length of the radius. And that's what we were looking for. All right, last letter here. Again, it's a cube. So we already talked about those cube formulas back on the previous page. So knowing that the total surface area of a cube formula is 6s squared. So I can just plug in that 384 equals 6s squared. I'm going to divide 384 by the 6, which gives me 64 equals s squared. And of course, when I square root, I'm going to get 8. But I'm not done, right? This is a two-parter because I clearly can see that they want me to find the volume of this cube. But I can't find the volume without the side length, right? So we just solved for the side length using the surface area formula. So now we're going to use the s cubed formula, right? And now that each side is 8, well, then that means that the volume of the cube, right, is going to be 512. Let me double check my math. Yeah. So 512 cubic meters. Right, so be really careful on those 2 to 3 part questions, right, where you're using one formula to solve for a variable so you can plug it into another formula. Make sure that you're paying attention and you're actually solving the whole thing. Okay, these last few questions, right, most of these are SPOV questions, right, so they're pretty easy. They're multiple choice, but we're still going to show all our work, right, if necessary. So here we go. Solid A is similar. I'm going to highlight that every time I see that word because that means SPOV chart. If the volume of solid A is 3240 and the volume of solid B is 15, find the ratio of the surface areas. So this is totally just a SPOV chart question. These are really big numbers though, so I'm still going to actually do my SPOV chart. And it's giving the volume, so they've given me enough information to put in the volume ratio is 3240 to 15. I'm pretty sure that's reducible, so let's go ahead and try to divide that. Looky there. So this reduces, and you don't have to do this, but I find it much more convenient to work with smaller numbers. So instead of saying the volume ratio is 3240 to 15, we can say it's 216 to 1. Okay, so I need to fill in the rest of my SPOV chart. Well, the only way I have to, if I'm given the 3D, I'm going to cube root to get back to 1D land, right? And the cube root of 216, again, you can use your calculator for that. I got to fix that crooked line. So we're going to cube root, put little notes in here. There we go. So the cube root of 216 is 6, and the cube root of 1 is just 1, which of course means the perimeter ratio is also 6 to 1. But of course the area ratio would be the square of that, which would be 36 to 1. And the question clearly says up here, it says find the ratio of the surface areas, which means I want the A column, right? And so that's giving me D as my answer choice. I don't want to do that. Circle. Okay. All right, hopping over to number 12. So cone A has a radius of 12 and cone B has a radius of 36. If the cones are, keyword, similar. All right, so as soon as I see that, you know I'm making a SPOV chart. Oops. And of course, remember, radii are sides, right? I know they're not like sides, but they're one-dimensional lengths. All right, I'll put length. Right, so radius is a one-dimensional length, which means it's going to either go in the S column for scale factor or side ratio. So cone A has a radius of 12, cone B has a radius of 30. So that means I have a one-dimensional ratio of 12 to 30, which of course that can be reduced, which I would like to reduce to get my numbers as small as possible. Let's see, we can reduce by what, 6? So that's going to give us 2/5, which means my perimeter ratio is 2/5, which means my area ratio is 4/25. And when I cube 2/5, I get 8/125. So then it says, my question is, find the volume of cone B. Well, if I'm finding volume, right, then I should be using the volume ratio in my proportion, right? Because volume can only equal volume. So I know that 8/125 is going to go in here. And remember, this ratio is A to B, right? They told us that in the beginning. So it says the volume of cone A is 48. And what is the volume of cone B? Right, so just a quick little proportion. We're going to cross multiply. Let's see, 125 times 48. So that gives me 6,000, right? And then we divide that by 8, and we get 750. So voila, our answer is A. Okay, moving on. Almost done. Here we go, number 13. The volume of pyramid A is 704 and the volume of pyramid B is 297. The pyramids are similar. So I'm totally making a SPOV chart. They gave me the volumes. This is very reminiscent of number 11 right above it. So the volume ratio is 704 to 297. I'm going to type that in my calculator. 704 divided by 297. And I'm going to hit math, enter. And I'm going to have it reduce it for me. And that's 64/27. And those are perfect cubes, right? So that's so much easier to work with than the 704 and 297. So when I go fill in the rest of my table, I know the cubed root of 64 is 4. And the cubed root of 27 is 3. So my S and P are 4/3. And my volume ratio then would be 16/9. I'm sorry, my area ratio. And we can see from the problem that it says find the surface area of pyramid A, right? So that means I'm clearly using the area ratio in my SPOV chart. Remember, don't just use whatever numbers you want. You have to be very purposeful in the numbers you choose in your proportion because they have to be in matching dimensions. So I have to use the 16/9. Now you do want to be careful here because you're doing A to B again, right? The way that we wrote that down, right? And so it says, now it's giving you the surface area of pyramid B. So that needs to go in the denominator and you're looking for A, which is going to be up top. So just be really careful. And then, of course, that is the proportion that we're solving. So 16 times 153. And then we're dividing that by 9. And I'm getting 272. And then I see that answer over here. Be aware, right, that your other multiple choice answers on a test would be everything we would expect you to do wrong, right? If you weren't making your SPOV chart and picking your right numbers, right? So you just want to be super careful. Okay, number 14 says the surface area of a rectangular prism is 450 square meters. What will be the new surface area if all the dimensions right? Which means similar because all the dimensions are being affected. So that automatically means SPOV chart. I mean, I know you can answer this one in your head, but I'm going to do a SPOV chart every time they're similar. Are doubled. Well, if the dimensions are doubles, the dimensions are the sides. So that means my side ratios are going to be 2 to 1 because of the doubling, which means my perimeter is 2 to 1, which means my area is 4 times bigger and my volume is 8 times bigger. Right, so it says the surface area of a rectangular prism is 450. I set up my proportion. Again, you can solve it without a proportion if you want to. So we're doing surface area, which means we need the 4 to 1 ratio, right? And let's see, all the dimensions are doubled. So be really careful because the 4 to 1, so this is going to be the bigger one, which would be the new, like the new one, because the sides were all doubled. So the new one is the bigger one. And then the old original guy that they're talking about, right, with the surface area of 450, right, that's what's going, actually, I have that backwards, don't I? Sorry, let me erase this over here. Right, so what will be the new surface area if the dimensions are doubled? Oh, you know what? That's so funny. Sorry, I was fine. Let me just bring all that back. I don't know why I did that. There we go. Sorry. So the, I just lost my whole train of thought. Sorry. Too much talking in this video. So they gave us the old one. Sorry. So the old one had a surface area of 450 square meters, and we're looking for the new one that's 4 times bigger. Again, it's probably easy just to do this without, a proportion. So that's going to give us 1800. Okay, and that would be our answer choice C over here. All right, moving on. We've just got a couple of more of these. So number 15, the volume of a sphere. What would be the new volume if the dimensions are multiplied by a fourth? So once again, anytime you see the dimensions, right, it's referring to all the dimensions, which automatically means similarity, because all the dimensions are being affected. Plus it's a sphere. And all spheres, we talked about this in class, all spheres are proportional and similar anyway, because there's only one variable. All right, so all the dimensions are being multiplied by a fourth. So that is our scale factor, which means the perimeter, which doesn't make much sense, is 1/4. The area ratio is 1/16, and the volume area of ratio, sorry, is 1/64. So we want to know what would be the new volume. So that means I need the volume formula, right? And it says, what would be the new volume of the dimensions, if the dimensions are multiplied by a fourth. So our new one is going to be smaller, right, than the original old one, right? So the old volume was 2240, and we're looking for the new one. So clearly we're dividing by 64, right? So if it confuses you to do the proportion on stuff like this, and that's okay, right? So I'm going to cross multiply and get 64 equals 2240. I'm going to divide that by 64, and I'm going to get 35, which is answer choice D. All right, last multiple choice. Here we go. How many times larger is the volume of a cylinder if the radius is multiplied by 3? Now this one, you got to be careful because we're talking about a cylinder, and cylinders don't just have radii, they also have heights. So this is not a SPOV question. So I'm going to put like no SPOV, right? The way that this is worded is it doesn't say all the dimensions are being multiplied by 3. It just says the radius only. So again, we talked about this in class. You can either do this in your head or you can manipulate the formula. I know the volume formula of a cylinder originally is pi r squared h. So if I multiply the radius by 3, I need to recognize that in the volume formula, the radius is getting squared. which means if the radius is getting, if the radius is getting squared, then the effect on the radius must also be squared. So this is going to turn into 9 pi r squared h. And when I combine that original untouched volume formula to the new one after I've tripled the radius, I can clearly see that it's 9 times bigger, right? And so that's why our answer choice is C, right? So no SPOV here because there's no similarity because we only affected a single dimension and not all the dimensions, right? So you want to pay really close attention to the wording, okay? All right, 17, kind of more of the same, just without multiple choice here. How many times larger is the surface area of a cube if the length is tripled? Now, cubes are like spheres, right? All cubes are similar because there's only one dimension because it's just side length, right? So we can actually, this is the one surface area formula that we like that actually doesn't have a plus sign because remember the surface area of a cube is 6s squared. Right? So if I manipulate that and the length is tripled, now it's not just s, it's 3s. But again, and again, you don't have to do all this work. This is just kind of explaining it on paper, right? What you can kind of think about in your head. Clearly the s in the formula is squared, which means the effect on the s must also be squared. So my surface area is going to be 9 times larger because of the 3 squared. If you want to finish this off, you can, right? But you're going to get 9s squared times 6, which total would give you 54s squared. And when I compare 6s squared, which is the original formula, to 54s squared, right, I can clearly see that it's 9 times larger. But again, you don't have to do all that work. I know it's 9 times larger because the s is squared, therefore the tripling must be squared, right? All right, I'm going to keep doing all that work though, just to kind of visually explain what's going on. All right, how many times larger is the volume of a cone if the height is doubled? Well, the height is only one of the variables of a cone because cones also have radii. So this is definitely not a SPOV chart question. So I'm going to go ahead and do all my work. So how many times larger is the volume? So the volume is 1/3 pi r squared h. Again, you don't have to do all this. So 1/3, let's see, what are we doing? We're only doubling the height, which is awesome because the radius is staying put. And all we're doing is doubling the h. Well, if all I'm doing is doubling the h, then all I'm doing is doubling the volume, right? And so that's my answer. But if you want to finish this off, you can, right? The 2 is going to get multiplied by the 1/3, which is going to turn it into 2/3 pi r squared h. So again, I'm analyzing how much bigger is 2/3 pi r squared h than 1/3 pi r squared h, right? It's 2 times larger. All right, I'm going to keep it rolling. We're almost done. How many times larger is the volume of a sphere if the radius is multiplied by 5? Now, if you want to, you can manipulate the formula, but remember, spheres are always similar to one another. So I can totally use a SPOV chart to answer this question. And of course, again, you can of course do that in your head. If the radius is multiplied by 5, well, the radius is a one-dimensional measurement. So that means the perimeter is also 5:1. All the surface areas would be 25:1. And the volumes would all be 125:1. So how many times larger is it? It's 125 times larger. And again, you can manipulate the formula if you want to, right? But it's just not necessary to do all that work when you could just think about it from a SPOV chart perspective since it's all similar. All right, let's see. How many times smaller which is weird when you say it that way, but anyway. How many times smaller is the volume of a cylinder if the diameter is multiplied by a half? So this freaks people out sometimes that it says diameter is multiplied by 1/2, because there's no diameter in the formula. But guys, you can basically cross out the word diameter and you can write radius. Because if the diameter of a circle is getting cut in half, then the radius is also getting cut in half. It's the same effect, right? Let me just explain that again really quick. If I take a circle, let's say has a diameter of 12, and I cut that in half, now I have a circle with a diameter of 6. Well, notice his radius is 6 and his radius is 3. So whatever I do to the diameter, I can just replace it with radius, and you're doing the exact same thing. Okay, so it's just kind of there to be tricky. Okay. All right, so how many times smaller? So we're talking about volume of a cylinder. We've done this lots of times. So volume is pi r squared h, but we're going to manipulate that and cut the radius in half. So now it's pi half r squared h. And we've talked about this so often, right? We have to recognize, if you want to do this in your head, you have to be like, oh yeah, because the radius is getting squared in this formula, so the effect on the radius must also get squared. So that's going to give me 1/4 pi r squared h. And then you're just doing that comparison from pi r squared h to 1/4 pi r squared h. Oh, that's all crooked. Sorry. It drives me crazy. There we go. All right. So we've obviously gone from 1 to 1/4. So it's 1/4 the original size, which is how I like to write it. And you can... So it's 1/4 the size. All right, number 21. How many times smaller is the surface area of a sphere if the radius is multiplied by 1/4? Okay, well, again, it's a sphere, and all spheres are similar. So I can just put that information in a SPOV chart if I need to. You don't have to. But it says the radius is multiplied by 1/4, which means the 1/4 is the scale factor in one-dimensional land, which means the perimeter is 1/4, which means the area is 1/16, which means the volume is 1/64. So when it says how many times smaller is the surface area, that means I clearly want to just pull my answer directly from the A column. So the surface area would be 1/16, the original size. Or 1/16 the size of the original. That might be a better way for me to say that. Okay, 2 more. Here we go. I like this question. There's nothing really like this on your test, but it's a great preface to a calculus type question, and it's nothing beyond the scope of your ability to do this, right? So it says, what is the volume of the solid created by rotating the figure bounded by these lines? So we're basically just graphing these 3 algebra lines. So y equals x, right, is the parent linear function with a slope of 1, right? So here's y equals x. And then y equals 0 is the equation of the x-axis, right, because you're crossing the y-axis at 0. And then x equals 6 is a vertical line, 2, 3, 4, 5, 6, right, crossing the x-axis at 6. I love this question. So we want the 2-dimensional shape that's being bounded, right, so boundary lines by these 3. And I'm hoping you can clearly see that the shape that's being bounded by these 3 lines is a right triangle. And of course, I did fail. I'm so sorry. I did fail to tell you which axis. We're going to make this easy. We're going to rotate it around the x-axis. because he's sitting on the x-axis. So we're going to go ahead and make that the rotation. Okay, we're going to make it easy on ourselves. So he's spinning around the x-axis this way. And of course, hopefully we all remember that that's then going to make a cone, right? So let's see. 1, 2, 4, 7. If I kind of graph his reflection buddy, is that enough? No, it's going to go right there. Sorry. Right, and then it's going to be rotating, right? So we're going to have, of course, it's never going to make a nice pretty oval for me. Oh, hey, just got lucky. All right, so there we go. So we're trying to find the volume of that cone, right, being created by that right triangle that's rotating around the x-axis. So at the end of the day, it's not that difficult of a question because we know the volume of a cone, right, is 1/3 pi r squared h. And the coordinate plane is giving us all the information we need, right? The radius, right? If we 1, 2, 3, 4, 5, 6, right? So the radius is 6. And the height, 1, 2, 3, 4, 5, 6 also, obviously, since it's going out to x equals 6. So the radius is 6, the height is 6. So we just have to plug all that information in. So 1/3 pi 6 squared 6. And that's 2 times 36, so 72 pi. And I'm just going to put units cubed since we're on a coordinate plane. Okay. So it's an interesting little question, right, where you have to graph the boundary of that solid first. All right, and then lastly, these are quick, right? These are all just cross-section questions. And again, on your test, you're only going to be asked about parallel to the bases and perpendicular to the bases, right? So we don't have to think too hard about these questions at all. So, and the bases are shaded in blue, by the way. So you don't have to really guess where the bases are. So basically, if I slice parallel through this rectangular prism, well, clearly my cross-section is going to be a rectangle because that is the shape of the base. And guys, that's always going to be, here I'm going to put base shape. When I slice parallel to the base, my answer is always going to be the shape of the base. Okay. All right, if I go perpendicular, well, then it's also going to be a rectangle. And of course it's going to be a rectangle because those are the shapes of the lateral faces, right? So lateral face shape, right? If all my lateral faces are rectangles and I slice it vertically, then I'm going to get cross sections that are all rectangles. And we can kind of use that same knowledge to go all the way across here, right? So on the second one, it's a triangular prism. So clearly if I slice it parallel, now remember, this one's not sitting on its bases like the first one. If I slice it parallel to the bases, right, then I'm going to get a triangle because that's the shape of the bases. All right, but if I go perpendicular to the bases, well, then I'm going to get a triangle, right? So it's kind of like if I do this and this and this, right? I'm going to get different size triangles all the way down. I'm saying rectangles. Sorry, I don't know why I'm saying triangles. All right, now this one, it's basically the exact same picture except they're right triangles. So I'm just going to be more specific that my parallel to the bases cross section is going to be a right triangle, but then of course all of my perpendiculars are going to be rectangles because that's the shape of the lateral face. Cubes, it doesn't matter how I slice it, right? Vertical or horizontal, I'm going to get a square every time. Again, this is only for parallel and perpendicular cuts. Obviously, if I was to like slice it at a corner, that wouldn't be a square. Right, but we're just doing parallel and perpendicular. All right, then we're just going down here really quick, right? Pyramid, same thing. It's going to be the shape of the base, right? So if I slice through it horizontal or parallel to the base, then I'm going to get a rectangle. Now, if I go perpendicular to the base, we talked about this in our notes. If I go through the apex, right, then it's going to be a triangle. Right? However, if I don't go through the apex, right, if I go through, straight through this point, right, then I'm going to have a trapezoid. So it depends. Perpendicular to the base, if I go through the apex, clearly I have the full triangle. But if I'm going through the side, I'm going to be getting a trapezoid. Okay. And you can write little notes there to yourself if you need to, right? Triangle is for the apex only here. I'm going to draw. I'll draw that picture again really quick. A little neater. So there's the triangle if I go through the apex point. Right there. Right. And let me pick a different color. Right. But if I slice through right here, right now I have a trapezoid. Right. And that would be my cross section right there. Okay. All right. The next one is a triangular pyramid. So, of course, if I slice through it horizontally, I'm just going to get a bunch of triangles. All right. Progressively getting bigger as we get closer to the base. And then if I slice through the same thing, right? If I slice through the apex point, right, I'm going to get a triangle again, just like we were talking about before. Okay, and that's really the only one I care about. So I'm just going to write that down for right now. And then, of course, cones, right? If I slice parallel, same shape as the base, so I'm going to get a circle. Right? And then if I slice through the apex, which again is the only one I care at all about, right, then that's going to give me a triangle going through the apex. If I don't go through the apex, then that gives me the hyperbola, right? But you don't have to know that for the test. So we're just going to talk about the ones going through the apex point for those last two. It's okay. And then, of course, for a cylinder, all my horizontal cuts would end up being circles because that is the shape of the base. And of course, if I go perpendicular, and let me go at a slant. If I go perpendicular, right. Oh, that's horrible. Let me fix that mess. Here we go. Let's go up first and then over. There we go. All right, so anywhere I slice through my cylinder vertically or perpendicular to the base, we are going to get a rectangle. Oh my goodness, y'all. Okay, that was a lot. So there is all of the work for the review and everything explained. Hopefully that all makes sense.